Great. For part 2 of day 3, we have a slightly different logic. This time the description is quite long and a bit complicated. I had to read it twice to understand what it's asking, but in reality it's relatively simple. What we have to do is to operate over a prefix of bits. So we look at the first bit, we see whether 0 or 1 is the most common value, and then we have to filter the whole list. So we keep only the lines, only the numbers that have the first bit set to 0 or 1, depending on whether it is the most common or least common value. So for example, let's say the 1 appears the most time, we keep only the values that start with 1. Once we filter the list, we do the same for the second value. So we take the 0 or 1, the value that is most common in the second position after we filter the list, and we filter this again. And we take again the third value. On the filtered list, we filter, and at every step, we basically build a prefix. We keep only the values that start with this prefix, and we go on until we have only one value. That value is the result. We do that twice, one because we want the most common value, so every time we filter with that criteria, and the second time because we want the least common value. Once we did, we get the two values that are the result of the filtering. So we filter until we find a single value, and once we do, we have to simply convert these two values to the we put it in decimal, we multiply, and that's the result of the problem. So let's start by looking at the solution of the part 1, and notice that we have a lot in common, because in both cases we have to filter the whole list. Sorry, in both cases we have to go through a list of binary digits and get the most common element of the two. So this operation of counting the lines and getting the amount of ones is actually something that we have to do in both cases. So what we can do is to create a function that I call count zeros 1, let's say. This function will get a list of lines, or better, a list of numbers, which is a list of strings. This is the type hinting in Python. I didn't do so far for simplicity, but in this case can be useful. And what I do is simply I copy the whole thing that I had in part 1. I put it into this function because I can use it later as an helper. This function will get a list of numbers, will iterate over the numbers here, and then we give us the amount of ones, so return ones. And just to be sure, we also want the amount of zeros. What is the amount of zeros is simply the same values that we have ones, but by subtracting the complete length. So we say that count, which is the amount of lines in the file, count minus the value in ones gives me the amount of zeros, essentially, because the sum has to be equal to the number of lines. So I say the value, so count minus value for the value in ones, and that's it. This is a list comprehension, which simply builds a list by iterating over something else, some other list or iterable, and applies this condition. So basically for every element in ones, it does count minus v, and that element is put into the new list that is built on the fly. So this is the list with the same size of ones, but is exactly the opposite. I can write the type signature, it's not necessary, but is nice to have. And this is a list of integers and another list of integers. Notice that since I called this function count 0 ones, it seems natural to me that one expects the first element returning the tuple to be the amount of zeros and the second the amount of ones. And now what I say is zeros and ones is equal to count 0 ones. What I have to pass here? I have to pass the numbers as a list. So what I do is I read f. So I read the complete content of the file and I split by the new line. And yeah, this now this can be done in a nicer way. So we can say ZO for 0 and 1 in zipping zeros and ones. Now we say that if the amount of zeros is greater than, the amount of ones is greater than the amount of zeros, we do this, otherwise this. So essentially I simply rewrote the function in part 1 to use this helper. This will be useful for part 2 because you can reuse this function and have some nicer logic. What I do now, I simply check what happens here. I check that the part 1 is still working after this change. Usually you write a test for this, but I really don't care about in such a simple problem. Okay, what is happening here? In line 11, idx. Okay, we don't really have to count because this is the length of numbers is the count. So len numbers is already the count. I don't have to count on the fly because previously I was reading a file. Then we say that if once is none. Okay, this seems correct. So what is happening here? That's weird. So what is happening is that once is initialized to a value that is this is out of range, which means that at line 9, when you assign the value, when you increase the count of the ones, we have the value once, which is a list that is too small. So there are essentially two cases. Either we initialize the list to the wrong side, or we are reading a line that is for some reason longer than the others. So let's see briefly if there is any value that is longer than the others. I don't think so. Would be very strange because we already passed the solution of part 1. Okay, let's put a breakpoint here and let's run the code again. Now I have line, length of line is 12, yes, and once as a length that should be the same, 11. Yes, because now I already split by new line. That was the issue. I split by the new line, so the new line is a character that is not anymore in the file. So this now should work. Yes. So I get a value. Now we simply readapt the solution of the part 1 to extract a piece and have it into a separate function. Nice. Now we do the same for part 2. So again we reset the file because we want to read again. In fact, we could just do this. So numbers is a value that now is passed from the outside. So the main will simply calculate the numbers like this. This actually should be lines, maybe more than numbers. Pass the lines to the function, so there is no need anymore to do all of this work. For consistency, I rename numbers into lines, and I rerun again, see that it works. Okay, now I have this function, part2, which finally can actually work on the problem. So what does part2 do? It has to iterate over the lines and build the prefix that contains the that indicates the most common and least common digit in a given position, and then it builds the prefix by filtering the list on the previous prefix, finding the new most or least common value at the new position, and filtering the list again. It filters again and again until it finds a single element. So let's say that I start with zeros. So I start with the prefix, and I say that the most common prefix initially is empty. Then I have lines. Lines is a list, and I am going to filter this list. So I say that until this list is has more than one element, I have to filter more. So what I do is I find zeros and 1 in the list of the lines. So basically I'm simply counting it, and what I want to do now is to find the element which is the most common between two. Another thing I need to do is to know at which point I'm of the iteration. So I just say that if 0 at the position which is the length of most common prefix zeros. Okay, so let's say the most common prefix is the length of the index. So the index is the length of most common prefix, which means how long is the prefix? What is the digit at which we have to do this thing? We could also use a separate counter, but since this is also the length of the prefix, we can use a single variable to do both. Now we say that if zeros, so if 0 at the index is greater than 1 at the index, what happens now? I'm finding the most common. So I say that if zeros are greater than 1, then the most common prefix gets at 0, because zeros are most common at the position. Otherwise, we add a 1. Notice that here I put a greater than, not greater or equal, because the problem states that in case of equality we want 1 to be added. So basically we favor the 1 in case of doubts. Now we have the prefix, but what we have to do next is to filter the list. So we say that lines is now equal to every element in the lines, so L for L in lines, when they start with a new prefix. So if L starts with most common prefix, and then after I did it, I just return the most common prefix, which I return lines of 0, because lines at this point will have a single element, and I can just see it. Let's see if this works. Okay, so it returns a value. Fine. Now we have to do the same for the least common prefix. This can be done either by copy-pasting this part, or by noticing that the only thing we have to change is this condition. So I say that the criteria is, let's say, high. So I say that either 0 is this thing, either zeros and 1s have this condition, and criteria is equal to high. So essentially I just make it conditional. Okay, high. Or I have to do this. I find it a bit unreadable like this. Let's split into different ifs. This because we have a different behavior in case there is equality. So I prefer to use different if blocks, even if there is some repetition, because it's just much more readable. And I think readability is much better than elegance or being short. We do not have to pay for the amount of code we write, so we can put something more clear. So we said that if criteria is high, else if criteria is low, elif. So I'm just splitting the case, else raise value error unknown criteria. So if the criteria is low, then we have to check that zeros are strictly lower than ones. Otherwise we if there are less zeros than ones, then we take the 0, that's correct. Otherwise we take the 1. Notice that in this case we want 0 to be strictly lower than ones, yes, but also when they're equal we want to take it 0. So this is slightly different than the first case. So now if I run again I should get the same result, yes. Another thing to fix is that now most common prefix is not actually most common, is just the prefix, which is also easier to read. So I just call it prefix. And that's it. So let's see what happens if I invoke this function with the other criteria. So criteria equal low. In fact, I think it's better to not have a default criteria here, but always pass it. So I avoid this confusing behavior of having secret criteria that is not, there is no reason to choose one or the other, so I just show all of them. And now I have two numbers. Fine, so this is what we want. And the problem, if I understand correctly, wants just the multiplication of these two values. So let's do it. Instead of returning the lines of 0, I just return the value, because nobody cares about the integer value. Or no, let's do it let's do it in here. There is no reason to to return the value. Nobody cares about the the binary representation, and it's easy to get one if you want to modify the code. So what I do, I just print another line in which I multiply part2 high low, or even better, I create an intermediate helper. So I say this is not part2, but this is find prefix. I don't remember how it was called in this thing. It was called rating, which makes no sense. I mean, it's just an exercise. Find rating. And now I define part2. Part2 wants only the lines, because the criteria is some detail of how it's implemented. So I would say that rating 1 equal find rating with the lines and then high, and then the rating 2 will be the same thing but with low, and this simply returns the product of the two. And this should be the solution. So in the main I simply invoke part2 once, because I don't need anything else. So this hides the implementation. I run it and I get this value. This should be the solution. unless I did some mistake, which is very possible. And it's correct. Perfect. I am very happy about it. And see you next time. Bye.